out figuring out one solution, get it fully working. Okay? That is my job in elements of software engineering. For other things, you're going to need in other class, basically they want to give you knowledge and expertise to take beyond this baseline. The baseline is giving any application, the specification. Different people will figure out different solutions. There are definitely better or worse solution in this space, right? So at this moment, I'm perfectly fine if you just come up with one solution, realize my full feature table. Okay? Then my job is done. Okay? Actually, this is a big deal. This is from 0 to 1. Other guys will take you from 0 to 100 and 1,000. But for me, my job here in this class is to take you from 0 to 1. Okay? I'm not teaching you how to efficiently track classes. I'm not teaching you how to quickly see something before other people. No, that's not my job. My job is, okay, no matter what, you're going to come up with one solution and get one system implemented of this size. Then my job is done. Okay? That is our core goal for this class. If you get given a problem, good or bad, you are coming up with a solution. Okay? Then if you go to network programming, they will teach you how to better build that client-server architecture and more efficient and everything. That's their job. Okay? So in this sense, if you have a solution space that have multiple different solutions, okay, then you are essentially searching for a better solution in that space. One thing you need to do is, okay, when you think about certain solution, no matter you like it or not, if you disapprove or approve that solution, you actually record that solution down and say, okay, I considered this before, so you don't go back there all the time. Just like this is similar to what we did in our quiz. Okay? If we keep a written record of all the discard solutions so that we don't go back to it. What functionality we implemented for our tree is similar to this. What we did on the tree is similar to this. We look at the solution space. We check each solution. It's not a good solution. We say this is not a good solution. We mark it. What are we doing here? Similar to what we do on our tree. If we are given this kind of solution space, what do we do here? Try to pick a solution. What do we do on the tree? It's very similar to this. We find a solution. Yeah, this one not good. Mark it. Move to the next one. What do we do on the tree? It's very similar to this.
You just keep looking and only return the best strategy.
What is that behavior on a trade? What do you do if you do the same thing on the trade? What are you getting?
The depth.
What are you getting? What is this solution strategy actually is? Similar to what we do on a trade. what functionality on the tray is similar to this? Search. Exactly. This is search. This is an aimless search in some sense, because this is a very complex graph. All right? But in your tree case, because it's simple, the structural tree is much simpler. You have much better, clear strategy for that search. You have BFS, you have DFS that's clearly defined, right? Why are you doing the BFS? You're just not doing something random because you don't want to go back to the same thing multiple times. And DFS and BFS all guarantee you go to one node once and only once, right? So that's the goal. Essentially, because this is a complex graph in our solution space, with many things going on, actually a lot of things unknown, so you are not able to do a complete search. You're basically do an exploratory search. That is where all the creativity coming in, okay? The step you take is the creativity you yourself inject into the search process, okay? So that you are looking for a better solution, all right? That is why so computer science, upper division education is all about, okay? Provide you the strategy in your search in the design space. For us, I'm happy with you come up with one solution and address this problem. Maybe it's a kind of not an optimized solution, but I take it, okay? As long as you get all the features checked out, okay? Get one solution. So most of the time, when it's the worst case if you don't have anything implemented. If you have something implemented, you can always optimize it. Okay? So this is also my recommendation to you in terms of solving all these programming problems. Always come up with a dumb solution first. Okay? Quickly come to a dumb solution, then optimize. Try not optimize too much on the front end. You're going to dig a hole and bury yourself into it. Okay? Try to come up with a dumb, complete solution which take you to the other end. Then you can say, okay, now I see the whole picture. I can optimize and I can optimize. Then you can always have partial solution. Partial solution will always give you more than half of the points. In our test, in any exam, you will see, and also in your interviews. Okay? If you go to an interview, if it's a problem, you should be able to figure out a solution, a dumb solution, quickly. If you don't figure that out, then you try to optimize at the beginning very hard and not coming to any solution. Your results are going to be worse than somebody just came up with that dumb solution. For instance, if you are asked to program, to do a program challenge, finish some program test online, if you write partial code that didn't do anything, didn't finish anything, you're not going to get a lot of points. However, you come up with a pretty dumb solution which actually finished the whole thing, you are actually going to get quite a bit of partial credit. Okay? Same strategy as we have here. Always come to a solution first. It's much easier to optimize a solution than try to come up with an optimized solution. Okay? Always come to a dumb solution first. All right. So let's look at problem we have with the specification, which tend to be almost 100% informal. Okay. So we do have things like, for instance, I mentioned that there are a lot of professors in our department working on functional programming language, and quite a bit of their effort is to be able to specify a program in a formal way. Okay? Then you may ask, that sounds like a great idea, right? If we can specify our program in a formal way, then that's all for good. Then probably we don't even have the Boeing problem of not testing their sensor input at all, right? So you would think that that's probably will never happen, right? why can't we just apply formal approach? Basically, everything right as like a mathematical formula, and prove a correctness, then move to the next stage. That sounds like a great picture. At least that was my impression when I was listening to all the full method classes. What's the problem with that kind of approach? Why aren't people doing it? Why are people writing specification in Mandarin, in English, and Hindi, and what have you? I mean, any kind of language. Why can't they just using mathematical formulas and proofs and everything, the functional language, what have you? Why?
Not everybody understands that.
First of all, not everybody understands that. I mean, it's probably take many years of education to master those kind of notation. Well, but why don't we get everybody trained up to that level? What's wrong with that approach?
Because that would leave me out of a job if they could do it all themselves.
Right. So certainly, yes, that'll take you years to stay in school before you make any money, right? Simply speaking, the efficiency is not there. Why Boeing is putting that aircraft in the sky without doing all these validations? What do you think? Why is that? You may say, "Oh man, 500 people dying. That's not a big. That's not a small deal, right? Why could they dare to put the aircraft in flight? Why?
They decided that settling the lawsuits would be less expensive than doing all the additional work.
You're right.
Or the pickup problem.
This is definitely the case. So basically, Boeing was trying to compete with Airbus. Airbus had a much better aircraft, came out, very much fuel efficient and everything. And Boeing saying, "Wow, man, we need to compete. Let's modify our most popular jet, the 737, give it a bigger engine, right? So it's fly faster, right? Better efficiency with all the engine fuel consumption." They didn't have time, didn't have the money to fully evaluate, fully redesign this aircraft. So basically, they take the old design and just add an engine.
Although you would think that if they were using the old design for the leveling system, that it would still work.
No, it won't work because the new engine is much bigger than the old engine. So if you take down the old engine, just install the new engine will be on the ground. Okay? Then your aircraft wouldn't be able to move because it'll damage the engine right away. You are basically not sitting on your wheels, you are sitting on your engine, right? So essentially say, "Oh man, we need to basically change the wing a little bit, push the engine up, okay, into a higher position relative to the aircraft. Then we put it in flight." However, the problem is you immediately change the aerodynamics formula of this whole aircraft. Then you have this. You basically, it's very easy for your aircraft to be like this. If your aircraft be like this, then your aircraft wouldn't fly fast because all the air is pushing you back this way. You have to have this nice angle, right? So you can fly the best. However, this is exactly the situation. Once it becomes this, they have software basically say, "Okay, let's push it back down." Okay, always push it back down. However, that software is activated by one single sensor, which fails all the time. Last year, among all the aircraft, FAA received 100 report of damage system. Okay, so that is the situation. Look at. Basically, if you are going to do specification, the cost of doing totally formal specification would be too high even Boeing, such a big company, wouldn't be able to afford. Cost, efficiency, right? We cannot train you guys faster to meet the industry demand. If we introduce 5 more formal classes, I mean, industry will rebel. I mean, so where are our employees? We need them finish in 3 or 4 years, not 5 and 6 years, right? So essentially we start with basically using a formal specification. Then we immediately know the problem. You guys are suffering through that problem, which is called ambiguity. Okay, you have a Chinese-speaking project manager who is thinking about one way while you are thinking about the other way, and now you need to reconcile with him to make sure that you understand his informal specification. You may say, oh man, if I go out to work, everybody speaks perfect English, then they write perfect English, then no problem, which is absolutely not true. Okay? So essentially, ambiguity will be a big problem. You are going to waste a lot of your valuable working hours dealing with ambiguity in your specification. Okay? But the root cause is our specification, even using things like use case diagram, user stories, inherently they are still informal English-based specification, natural language-based specification. Natural language is nowhere near mathematical proof or far from it. Okay? So ambiguity is a big problem for you guys to deal with in the future. Okay? It basically, just how do we deal with ambiguity? Iteration by iteration. We just iterate. Oh, it's wrong, do again. Oh, it's wrong, do again. Until, okay, we agree, now it is. What do we agree? That's how we deal with ambiguity today. Certainly you can say, oh, well, we'll use formal specification. I'll give you an example, right? So this is an example from many years. All right? So basically, if we have highly trained specification writer, like PhD in computer science, informal methods and everything, then this problem will be totally solved. Right? Then this actually shows this simple text processing case study, which is this. All right? So given a text consisting of words separated by blank and new lines, converted in line by line form to in accordance with the following rule, line breaks must be made only when the given text contains blank and new line. Each line is filled as far as possible, as long as no new line will contain more than this number of characters. Let's not try to understand this in a very detailed way, but say, okay, this is not a big deal, right? Well, so to be honest, anybody here can handle this, right? This is essentially a tokenizer. In fact, we don't even implement this anymore because we have built-in tokenizer already. This may be a solved problem. Okay? Anybody here can write this. Right? This is a solved problem. We don't even think this is going to be an ambiguity here. Then, well, in 1970s, this is a big deal, right? Computer can process text. That's a big deal. So it's actually worth a scientific paper to write down the algorithm. Okay, so the words say, oh great, I'm going to write 25-line Augur program, and then I'm actually going to do an informal proof and show it's correct, then that's the end of the story. Right? Simple thing, you want to tokenize, we will give you an algorithm, implement the algorithm in a programming language and show it's perfect, and everybody move on. Publishing a scientific paper. Well, reviewer come back and say, oh, guess what? Here I found a bug. Your informal proof is insufficient. Go back and change your algorithm. Okay, these are professional computer scientists with formal training. Okay, it's great. I mean, reviewer come back and made a mistake, so I fix it. Guess what? Once it's published, Well, 3 more faults got detected. In this 20-line program, okay, proved informally and verified by a reviewer, then now you have no confidence in scientific paper, right? Most of our scientific paper, you cannot even reproduce them, okay? That's a huge difficulty in scientific community. You take a paper and you say, okay, I'm going to reproduce this. No, you cannot reproduce them. All right? So this is only 20 lines. I mean, that shouldn't be too hard. That's what people keep finding problems with this 20 line of code for years. Okay? If we have the best scientists working on this, we cannot even get 20 line of code right. How could we get 50,000 line of code right? 500,000 line of code right? Okay? Just a sheer effort into this to make it an intractable problem. This can continue even into, I mean, 15 years after the first publishing of that, people are still finding problems with the specification. Eventually, I mean, basically natural language is not a great way to specify a product, but we are using it anyway today. Because this is the, so right now, the most cost-efficient way for us to write specification. May not be the best way in the sense of getting rid of bugs, but it's a cost-efficient way right now for us to operate on. So we are still, so you can see that even ever since we have computer, we have been using informal specification in natural language, and today, even today after, I mean, how many years, 70 years maybe, we are still using the same way to specify our product. All right? All right. So this is actually, say, people say, oh man, we still